Hello everybody, welcome into another lesson and welcome to the brand new unit of exponential and logarithmic functions. Today is going to be part one of exponential functions. We are going to use the graphing approach to helping you understand what an exponential function is and how it works. So in the past, we've dealt with polynomial functions where you would have something in the form of like y equals x squared. Now, in exponential functions, this reverses. Here you have y equals 2 to the x power. This is considered an exponential function because your variable is the exponent for once, and then you have some base, which is a number. So here you have y equals 2 to the x. We're going to graph this to help you understand it. So let's start at 0, right? When x is 0, so you take 2 to the 0 power, what's that? You get 1, right? So when x is 0, y is 1. So we'll plot the point 0, 1. Now, what about when x is 1? So that would give you 2 to the first, right? What's 2 to the first? That would be 2. So you'd have 1, 2. Now, let's put in 2 for x. So when you have 2 to the second, what do you have? You have 4. And then let's do one more. How about 2 to the third? So when x is 3, you have 2 to the third, what do you get? You get 8, which will put you all the way up there. And as you see, it just keeps getting bigger and bigger. Now, what about when x is negative 1? So what is 2 to the negative 1 power? Well, that's the same as 1/2, right? So when x is negative 1, that'll put you about right there at 1/2. Okay, now let's put in 2 to the negative second. What is that the same as? 1 over 2 to the second, which we know is the same as 1/4, right? So at negative 2, you're about right there. And then let's do 2 to the negative third. When x is negative 3. Well, that's the same as 1 over 2 to the third, which is the same as 1/8, right? So negative 3, it's about 1/8. And then as you see, the more negative you get, the smaller it gets. Let's go ahead and graph this. We have sufficient points to graph this now. And let's go this way here. And what do you know? That is roughly what the graph of y equals 2 to the x looks like. Okay? Now, notice something here. We notice something. Now, the more positive your x's are, of course, it grows exponentially. This is why it's called an exponential function. It's growing exponentially. If I put in 4 for x, I'd be all the way up to 16, right? But notice the further left I go, I keep getting smaller and smaller. If I put in x being negative 4, I would get 1 over 2 to the fourth, which is 1/16. If I made x negative 5, I would get 1 over 2 to the fifth, which would be 1/32. The numbers get exponentially smaller and smaller. They get really close to 0 for your y value, right? It gets extremely close to 0, but it never actually reaches 0. Why is that? Well, the idea is that 2 to no power whatsoever will give you 0 itself, or anything negative for that matter. So the line y equals 0 is called a horizontal asymptote. So y equals 0 is what's called a horizontal asymptote. asymptote. That's how you're going to spell that. Asymptote. An asymptote is a line that you simply cannot cross. It's a line that you can't cross. You can get infinitely closer and closer to it, but you'll never actually reach it. And it also helps to guide the shape of your curve. So that's basically what an asymptote is. And if you have a number to any power, it'll never be, the y value, your output of the function, is never 0 or anything negative for that matter. So y equals 0 is your horizontal asymptote. Okay. Now, let's change it up just a little bit. Let's say I made y equal to 3 to the x. So this time y equals 3 to the x, right? Well, alright, so let's put in 0 for x. 3 to the 0 is 1. Actually, let's make these, each unit should be worth 3 units, right? Let's do that, because I'd like to go up to x to the third. So we'll say, yeah, it's going to be 1 still, right? 0, 1. But what about when x is 1? So you'd have 3 to the first, which is 3. Then when you make x 2, you got 3 to the second, which is 9. And then if you make x 3, well, 3 to the third is 27, so that would give you a y value of 27. How about when x is negative 1? That'd be the same as 1/3, which will really put you darn close to the x-axis. So let's graph this here. Notice something else. It looks very similar to 2 to the x, only it's 3 to the x. So exponential functions like this tend to have roughly the same shape. It may be stretched different ways depending upon what your base is, but all exponential functions of this type graph roughly the same, where y equals 0 is your horizontal asymptote. Now, let's change this again here. So I think you get the idea that any base greater than 1, if the base is greater than 1, you're going to get roughly the same shape we've been getting. The reason I say greater than 1 because, well, you put in 1 to the x, what are you going to get? Every value of x, you get a y value of 1. Even if you put in negative values of x, you'll just get 1. You would have a flat line through y equals 1, a horizontal line. So exponential functions only work of this type if the y value is not 1. The next lesson we'll talk about if the base is less than 1. We'll deal with that at that time. What if, okay, we had something like 2 times 2 to the x? Well, much like with polynomial functions or square root functions, that 2 times the 2x, that is a stretching factor. That is going to be a stretching factor. So let's graph this here, 2 times 2 to the x. Alright, so we'll make one of these units worth 2. Okay, so x is 0, what do you get? You got 1, and then take 1 times that 2, you actually have 2. So you would have the point 0.02. Now what about when x is 1? Well, that's 2 to the first, which is 2, times 2 is 4. So at 1 you'd be at 4. And then when x is 2, that's 2 to the second, which is 4, times 2, which is 8. And then what about when x is 3? So that's 2 to the third, which is 8, times 2, which is 16. Alright, so then this time, what about when x is negative 1? Well, that's 1/2 times 2, which would just be 1. X is negative 2, that's 1 over 2 to the second, which is 1/4 times 2, which would be 1/2. So all you've managed to do is stretch this, but it looks very similar to 2 to the x, you just have a stretching factor of 2. So the general form for an exponential function to start with is going to be an a times b to the x power. So what is the a? A is your stretching factor or shrinking factor if you had a fraction, which we'll deal with in a second. We will deal with that in a second. And then that b is your base. When, and this is the topic of today's lesson, when that a, your factor, is just greater than 0, it's any number greater than 0 for your shrinking or stretching factor, a greater than 0, and you have your base, which is greater than 1. If your base is greater than 1, what we have here is called an exponential growth function. So when your base itself, that b, is greater than 1, for example, like the 2 to the x, right? 2 is greater than 1, and then you have the stretching or shrinking factor, a, which is greater than 0. You have a 2 here for that. It's definitely greater than 0. This is exponential growth, because notice the more you keep increasing your value of x, it's growing exponentially, right? So that's what we're really going to be talking about today. Next lesson, we'll deal with negative exponents. We're not going to talk about that today. Which the next lesson will be an exponential decay function. But anyway, let's say now, this time I'm going to do 1/2 times 2 to the x. So I'm taking this 2 to the x times 1/2. Well, you have a vertical shrink of factor of 2. So 2 to the x, let's make x 0 again. Every unit will be worth 1, by the way. So when x is 0, 2 to the 0 is 1 times 1/2. That'll put you at 1/2. So you'd be at the point 0, 1/2. Now how about when x is 1? So 2 to the first is 2 times 1/2 is 1. Alright, how about when x is 2? Well, what's 2 to the second? That's going to be 4 times 1/2 would be 2. And then when x is 3, you end up getting 2 to the third, which is 8, times 1/2, which is 4. Heck, for good measure, let's even do x to the 4th. What's 2 to the 4th? That's 16 times 1/2, which is 8. And then what about when x is negative 1? Well, 2 to the negative first is 1/2. 1/2 times 1/2 is actually 1/4. That'll put us all the way down here. Let's go ahead and graph this. And it gets infinitely close to 0 again, but you have a vertical shrink factor of 1/2 since the a, your coefficient on this is less than 1, but it's still positive. Now, what if I did 2 to the x plus 1. So now we've just changed this a bit. I'm doing 2 to the x plus 1 power. So this is going to shift everything a little bit. So let's make x 0, right? 2 to the 0 plus 1, well that's 2 to the first, which is 2. So at 0 you'd actually have a value of 2. Alright, so then let's see, x is 1, so 2 to the 1 plus 1 is 2 squared, which is 4. So at 1 you're already all the way up to 4. And then let's put in x being 2. Well, 2 to the third is 8, so at 2 you're already up to 8. Now let's put in negative 1. Negative 1 plus 1 is 0, 2 to the 0 is 1. So at negative 1 you have 1. And then when x is negative 2, negative 2 plus 1 is negative 1. 2 to the negative 1 is 1/2. And then let's see here, you have, for good measure, let's do negative 3. Negative 3 plus 1 is negative 2. 2 to the negative 2 is 1/4. So let's go ahead and graph this. So you may sometimes also see it where you have you may have a number plus that x power. What that does is it just shifts everything that many units more. So x plus 1, it takes it to the next value of x, basically. That's what it is. That's more of that would be a vertical shift. No, that's a horizontal shift, rather. I'm sorry. 2 to the x plus 1, that'd be a horizontal shift. So all my x values, I'm just adding one more, literally. So we have this a times b to the x plus h. That's how we're building the general form. So you have another factor of h. That's simply how many units, like in a polynomial function or square root function, how many units left or right you're shifting your x values. Now, what if I made this x minus 1? I mean, you still get the same general graph, but your x values are shifted. So what if I had 2 to the x minus 1? Well, let's make x 0. So that'd be 2 to the 0 minus 1. 2 to the negative 1 is 1/2. So at 0, I'm all the way down to 1/2. What about when x is 1? 2 to the 1 minus 1 is 2 to the 0, which is 1. Now how about when x is 2? So 2 to the 2 minus 1 is 2 to the 1, which is 2. Then how about, let's see, when x is 3, so 2 to the 3 minus 1 is 2 squared, which would be 4. And let's even do when x is 4. 2 to the 4 minus 1 is 2 to the third, which is 8. And as you see, it's still getting exponentially bigger, but it's taking greater and greater values of x to do that. And then, heck, let's do x being negative 1. So negative 1 minus 1 is negative 2. 2 to the negative second is 1/4. So let's graph this. Alright, so still get that same exponential shape, but this is a shift either right or left however many units. So I've shifted my x values 1 unit to the right in this case when you have x minus 1, right? If I set x minus 1 equal to 0, I'm shifting everything 1 unit to the right. Whereas when it was x plus 1, I shifted my x values 1 unit to the left. So this a times b to the x plus h indicates how many units right or left I am shifting the function. And notice in general, so far, you still have that horizontal asymptote of y equals 0. Now, let's change this up a little bit. Let's change it some. So, let's say I take 2 to the x plus 1. So this time I have the plus 1 outside of the exponent. What is that going to do? Well, again, let's do 2 to the 0, which is 1, plus 1 is actually 2. Now, let's do 2 to the first, which is 2, plus 1 is 3. Alright, and then 2 to the second is 4, plus 1 is 5. And what the heck, let's do x is 3. 2 to the third is 8, plus 1 is 9. We'll be all the way up here. Now let's discover something interesting. X is negative 1, right? What do we have? That would be 1/2 plus 1 is, well, 1.5. Now what about 2 to the negative second? Well, that's 1/4 plus 1, that's 1 1/4. And then you have x to the negative third, well, that's 1/8. 2 to the negative third is 1/8 plus 1, that'd be 1 1/8. Do you notice something here? You're getting infinitely closer and closer to that y value of 1, but you're not actually reaching it. You're getting really close. In fact, this plus 1 changes, it shifts everything upward 1 unit. That is your new horizontal asymptote. Y equals 1 becomes your horizontal asymptote. I'm going to abbreviate asymptote a little bit. Y equals 1 is your horizontal asymptote. So the full form of an exponential function is that factor of a, that coefficient, times your base to the x plus h power, all that plus k. That k shifts either up or down vertically. So we have a horizontal asymptote at y equals 1. So you shifted everything upward. So now we can't have any y value less than 1. It'll get infinitely closer to 1, but there's no y value less than 1. Okay. Now, let's change it again here. Let's say I have 2 to the x, I have all that minus 1. So now I'm shifting downward 1 unit, right? I'm going to shift downward 1 unit. So when x is 0, 2 to the 0 is 1, minus 1 is 0. Alright, now when x is 1, well, that's 2 to the first, which is 2, minus 1, which is 1. And then when x is 2, that's 2 to the 4, sorry, 2 to the second is 4, minus 1 is 3. Then how about when x is 3? Well, that's 2 to the third, which is 8, minus 1 is 7. Okay. Now, how about when x is negative 1? Well, that's 1/2 minus 1. That'd be negative 1/2. How about when x is negative 2? That's 2 to the negative second, which is 1/4 minus 1. That would give you negative 3/4. And then for good measure, let's do 2 to the negative third, which is 1/8 minus 1. That'd be negative 7/8. So notice, I'm getting infinitely closer and closer to a y value of negative 1, but I'm not actually reaching it. So you can say that y equals negative 1 is your horizontal asymptote. So in fact, let me draw that real quick for your horizontal asymptote. So if you have a plus or minus in the exponential function, this plus k, that indicates a vertical shift either up or down for your function. And that plus k is always your horizontal asymptote, always. It'll always be your horizontal asymptote. So that's how you know what your horizontal asymptote is going to be. So that negative 1 here, that's a dead giveaway that y equals negative 1 is your horizontal asymptote. So now the full form of an exponential function is y equals a times b to the x plus h power plus k, where a is some coefficient on the exponential function, usually a shrinking or stretching factor, and we'll even talk about a negative a in a minute. And then this b is your base. In this case it was 2, but you could have 3, you could have any other base that's greater than 1. Or, no, that's greater than 0, really, not equal to 1. And then you have this x power plus h, so that's going to shift all your x values right or left, however many units you're dealing with, your depending upon what your h is. And then you have your k, which is always your horizontal asymptote, shifting it up or down 1 unit. Now, I'm not going to belabor this too much more, but what if this time I do y equals negative of 2 to the x. I take y equals negative 2 to the x. Well, it's going to get interesting. So what's 2 to the 0? Well, that's going to be 1. You negate that, you actually get negative 1. Now what about when x is 1? Well, 2 to the first is 2. Negate that, you get negative 2. Then what about when x is 2? Well, 2 to the second is 4. You negate that, you'll end up getting negative 4. And then when x is 3, 2 to the third is 8. You negate that, you'll end up getting negative 8. Okay, so then x is negative 1. What's that? 2 to the negative first is 1/2. You negate that, you get negative 1/2. And then when x is negative 2, well, so 2 to the negative second is 1/4. You negate that, you'll get negative 1/4. What do you notice here? Let's graph this. It's getting infinitely closer. The further left you go, you get infinitely closer to 0 for a y value, but you never quite reach it. So notice you have no plus k. You have no plus outside of this exponent. That tells you that your horizontal asymptote is still 0. The only difference is with this negative coefficient, you've reflected everything across the x-axis. So if you have a negative coefficient, that reflects the graph across it uses the x-axis as a mirror. Where the original, if it were just 2, if it were positive 2 to the x, it would be going up like this, right? So we've just reflected everything across the x-axis. All right, let's do one more here. So here's a fun one. Y equals negative 2 to the x minus 2 power, all that minus 3. Okay. So, if you want to find your starting point, take that x minus 2, set that equal to 0. So x minus 2 equals 0. That would give you that x equals 2. So basically what this means is you'll have a 0 exponent when x equals 2. That's going to be the focus of where we start. So when x equals 2, well, 2 to the 2 minus 2 is 2 to the 0, which is 1. Then you negate that, you'll get negative 1. And then you'll have minus 3, which would actually put you at negative 4. So when x equals 2, you'll be all the way down to negative 4. All right. Now what about when x is when x is 3? What's 3 minus 2? Well, that's 1. So 2 to the first is 2. Negate that, you get negative 2. All that is minus 3. So when x is 3, I'm sorry, that'd be minus 5. Excuse me, I don't know what I'm saying. Now what about when x is 4? So 4 minus 2 is 2. 2 to the second is 4. Negate that, you get negative 4 minus 3 is negative 7. And then you see it would just keep getting smaller and smaller. Okay. Now what about when x is 1? Well, 1 minus 2 is, of course, negative 1. So 2 to the negative 1 is 1/2. Negate that, you'll have negative 1/2. Minus 3, that'd be negative 3.5, which would be right here. When x is 0, that's 2 to the negative second, which is 1/4. Negate that, you get negative 1/4 minus 3. That'd be negative 3 1/4. So do you notice something here? It keeps getting closer and closer to negative 3 the further left you go. Well, that minus 3 should be a dead giveaway that that's your asymptote. That is your horizontal asymptote. So let's graph this here. You'll get infinitely closer and closer to a y value of negative 3, but you'll never quite reach it. So that y equals negative 3 is your horizontal asymptote. And that negative coefficient indicates that you're reflecting the exponential function across the x-axis. And then you've shifted all your x values to the right 2 units. That's what that x minus 2 equals. So that's it for this lesson where we talked about exponential growth. and we talked about having positive exponents. The next lesson we will get into exponential decay, which has negative exponents involved. Or let's recap real quick. So you have let me write this better. Y equals a times b to the x plus h plus k. All right. So if your constant that you're multiplying this by is greater than 0, and that base is greater than 1, you have exponential growth. That is exponential growth. And we've seen how everything grows exponentially. When you have a constant greater than 0, the base is greater than 1. That x plus h is just a horizontal shift left or right. That plus k shifts everything up or down that many units, and that k is also your horizontal asymptote, right? Next lesson we'll talk about exponential decay, where your a is still greater than 0, but b is greater than 0 but less than 1. We'll talk about exponential decay at that time. So I hope everyone has a great day, and take care.